a big strapper, generally defined as a large, able-bodied truck driver. And for those watching this video, I'm sure you're well aware, in regards to 11-meter CB radio, we have a similar but different meaning of big strapper, which of course is a power station. But how many really know the origins of this 11-meter CB radio big strapper terminology? Hi guys and girls, Greg Howe, S9 Radio. And the old timers, well, wait a minute, I'm an old timer, but only mid-60s in regards to 11-meter CB radio. But the very earliest 11-meter CB radio old timers will tell you the term big strapper started right here. Back in the 60s and 70s, when tube rigs on CB were just about everywhere, there was a mod that was fairly common in regards to the high voltage power supply that involved strapping the surge protection resistor. Now this mod would easily show up as usually a half watt, sometimes even more than a watt of RF output power increase by strapping the power supply surge protection resistor. In this case is a Browning Mark III transmitter, and it's a 250 ohm resistor. So they've strapped the surge protection resistor, and technicians were well aware that strapping this resistor could cause some issues, burned out rectifiers and whatnot, the surge protection resistor designed to protect, because when you fire up a radio with high voltage or any electrolytic capacitor, they are at a dead short when at a zero potential, meaning no charge on them. So basically now the transformer and rectifiers are looking into a dead short with this surge protection resistor strapped. But there's some other evils to not only stressing the power supply transformer and the high voltage rectifiers to strap in this. It also removed most of the headroom from the high voltage supply, sapping your forward swing. But forward swing wasn't an issue in the 60s and 70s, as it was a terminology most of us had never even heard of. And a big reason for that is a lot of our sets didn't even have S meters. Same thing with solid state rigs. A lot of them did not have S meters. So most people only saw the benefits of strapping the high voltage surge protection resistor as increased output. But I'm going to show you one of the negative, well, I'm going to show you a few of the negative side effects of being a big strapper. Even though I was quite active in the 60s and 70s on 11-meter CB radio, I had always thought the term big strapper just meant a power station, but the old timers tell me a big strapper was really a term used for technicians who would do this modification and for the owners of the radio gear that had been strapped. They were known as big strappers. Consequently, they had a little better signal than many of the people because linear amplifiers were really much of a taboo. As a matter of fact, there were radio shops where I grew up in the Los Angeles area. If you walked through the door asking about where can I find a linear, they pointed their finger and showed you the way out. Seriously. So linear amplifiers were not terribly commonplace. Microphones like the Turner preamp were a great way to increase your station's reach as far as the signal. And then, of course, this power strapping mod here was also a way to squeak an extra half watt or a watt out of your radio. And, when you're dealing with a legitimate 4-watt signal and trying to talk to somebody 25 miles away, this was a useful modification. And, CB repair technicians that were capable of working on tube radios were everywhere. They doubled as TV repair shops, which were on just about every street corner in America. So if you did blow a rectifier or something due to the strapping mod, it was really no big deal getting the set repaired. Let alone the fact you could also walk down to your nearby Radio Shack and buy the part and fix it yourself, which most people were quite capable of. So anyways, there you go with the origin, I am told, from the old timers that got into the hobby in the very early 60s. The big strapper was really a technician or an owner of a strapped radio, which is now morphed into 11-meter power station. With the high voltage power supply strapping modification removed, I'm going to go ahead and key up the transmitter. There we go. I've got it in the AM mode looking into a Bird Tourmaline dummy load, and I can already see some orange glow starting to light up this plate structure, indicating this poor 6BQ5 modulator tube is working way too hard, and of course that's because we've got a shorted modulation transformer. The owner tells me that it actually blew 2 tubes before he realized there was a problem. With one of the tubes getting so hot it actually compromised the glass envelope, leaking down the vacuum, turning the whole tube white. And fortunately he had the covers on when he was unknowingly red plating the tube. I do not. I don't want a face full of hot glass, so I've unkeyed. But that's the red plating demonstration. And if you see that on any tube in any of your equipment, with the exception of a 3500Z linear amplifier tube and some of its cousins, they like to run red hot. Most tubes do not. It's quite common to see audio tubes and audio amplifiers red plate because the bias has not been correctly adjusted. And then if you're a long-winded guy like myself, yeah, I can get a 572B or just about any other RF output tube glowing pretty good. But it's definitely something you don't want to do. When you see that red plating, with the exception of a 3500Z, you're near disaster. Take it from a pro. I've been there, done that. And I'm sure a few are thinking, well, wait a minute. How can strapping the high voltage supply, which only adds a few extra watts of audio output to the 6BQ5, possibly blow out this modulation transformers? Brownings are solid designs. They're not flimsy. How can this possibly happen? Well, I'm going to tell you how it happens. In the world of audio, especially for what we do, it's highly desirable to have some good low frequency response, providing that nice, deep, rich sound that greatly enhances the human voice. However, both low frequency sine and sound waves are larger than their high frequency counterpart, consequently requiring more energy to move these low frequencies around. A stereo system is a perfect example of this. It doesn't take much volume to get sound out of a tweeter, but if you want some nice bass response, you're going to have to hit that woofer a little harder, giving it some more energy, just like an audio transformer. The harder you drive them, generally the better the bass response is, up until saturation when things get all distorted. In good designs, engineers are taught to run most components at about 60% of their maximum, whether it be a tube, a transistor, or a transformer. However, that design philosophy is out the window in regards to audio circuits that employ magnetics, aka transformers. And the reason for this is the best mutual coupling, which is responsible for the low frequency response, occurs when the transformer is run near saturation. So what the heck is saturation of an audio transformer, you ask? Well, much like a Formula One or a two-stroke motorcycle engine, which tends to offer the most performance just below redline and on the verge of destruction, the same thing holds true with audio transformers in regards to the passage of low frequencies. And engineers desiring a robust low frequency response like to run these audio transformers just below redline, aka electromagnetic saturation, as that's where the best electromagnetic coupling of these low frequencies occurs, when you pound them hard. Here's the specs on the 6BQ5 modulation tube, showing a maximum of 300 volts on the plate, producing 12 watts of audio output. However, on rigs that have been strapped, I've seen this plate voltage hovering around 400 volts, bringing the 6BQ5 well into the red plating zone as it approaches 17 watts of audio output and on the verge of destruction. Here's a little about America's oldest, largest transformer manufacturer, Stancor, an acronym for Chicago Standard Transformer Corporation, a brand with worldwide recognition and regarded as one of the best electromagnetic manufacturers to ever hit the electronics industry. And their audio transformers are so highly praised, they're actually good enough for Frank McIntosh and Saul Morantz's early audio amplifier designs, and we should be so lucky to have such wonderful audio magnetics in many of the electronics that we own, whether it be our stereos, our table radios, or in this case, communications gear.
And look at Stancor's specs, basically throwing their own product into a lion's den, speccing an undersized 11-watt transformer for application in a 12-watt 6BQ5 circuit. Yeah, Stancor knows all about saturation and how to get there.
With the 6BQ5 modulator tube red plating and the fact this Mark III transmitter had already destroyed 2 of them, with one of them getting so hot it almost grenaded, this was a pretty good indication that and these suspicions were quickly validated when checking the primary of this modulation transformer, with the factory spec being 150 ohms. As you can see, this one's coming in at 83.5. This is a newly purchased modulation transformer coming in at almost 143 ohms. I've got another new modulation transformer that comes in at 140 ohms, and that's just fine. It's still within the manufacturer's tolerance. So long story short is, if you've got a red plating modulator tube, there's a darn good chance it's this modulation transformer that's causing the problem. And there's a few things that can take out this modulation transformer. I've already showed you the strapping modification, but a catastrophic failure of the 6BQ5 modulator tube can also take this transformer out, feeding it way too much juice for way too long. So that's another possibility. And then, of course, if a golden screwdriver has been in the set, pretty much anything is possible. And let's keep in mind, this 6BQ5 modulator tube is a 12-watt device. However, when you strap the power supply, the entire audio chain starts driving the snot out of it, let alone the excessive plate voltage that's on here. And it really, really does brutalize this transformer. I'm sure a few of you are wondering, well, if this modulation transformer is going to burn out so easily, why not use a larger one? With the operative word being saturation. It's much harder to drive a larger transformer into saturation than a smaller one. And that being said, I'm sure most of you don't drive your cars full throttle, run your TV or your stereo full blast, and you probably don't run your radio with the mic gain full blast either. Now, the 6BQ5 modulator tube is a 12-watt device. Once again, I'm sure you don't run your radio's mic gain at full blast. Most of the Brownings will do about a 4 to a 6-watt dead key, nicely modulated with about 6 to 10 watts of audio floating across the plate of the RF output tube. So let's just assume you're going to run your mic gain loud and proud at a 10-watt level. Now, for demonstration purpose, we're going to call 10 watts of electromagnetic force as being equal to 1 teaspoon of water. Factoid: as an electron moves, it generates an EMF, an electromagnetic force, and so does a molecule of water. As water moves, it generates EMF, an electromagnetic force. Now, being as electromagnetic waves are kind of hard to see, for this next demonstration, I'm going to attempt to paint a little better picture, pun intended, of this phenomena of electromagnetic saturation. However, I will be substituting H2O in lieu of magnetic waves. As you can see, this teaspoon of water being equal to 10 watts of electromagnetic force for demonstration purposes brings this smaller transformer just below full saturation, which is basically audio perfection for those concerned with good low frequency response. And then having a look at the larger transformer, you can see it's just barely 50%. I wouldn't even call it saturated, hardly enough for optimal low frequency mutual coupling of the magnetic windings. Okay, enough of my rant on the importance of mutual coupling in regards to low frequency response. And as they say on the late night TV commercials, but wait, there's more. And yes, there is. There is another wonderful side effect to driving these audio transformers, whether you've got a tube rig or a solid state. Pay attention, solid state guys. This, what I'm about to say, holds true to you guys in regards to having a better, deeper, richer, low frequency response in all of your radios. Anyways, this benefit is known as harmonic distortion. I know a lot of you are thinking, oh God, that can't be good. But in the case of low frequencies and what we do with the human voice, this low frequency harmonic distortion, providing it's not overdone, is a huge benefit, as this creates a wider, much fuller, richer audio footprint, as I'm going to try to demonstrate in these diagrams.
I guess the best way I could paint a picture is imagine you had a home speaker system that had 4 woofers, and each one of these woofers was outputting a different frequency, and of course they all commingle at your ear. So you're going to get a lot better bass response. You don't have to have it loud, overbearing. I'll tell you, this is an audio technique the best in the business have been well aware of for a long time. Low frequency harmonic distortion. And all of you guys, whether it be tube or transistor radio, you want your radio to do the work. Back your mic gain way, way down. Let the radio's modulation circuit that is built to drive the modulation transformers near harmonic distortion. Your little preamp mic doesn't have enough audio to do this. Sure, it can drive the audio circuit and the radio harder, but you're really, best off running that mic gain just barely cracked open and letting the radio's modulation circuitry do all the work. And for this demonstration of low frequency harmonic distortion, I've intentionally chosen everybody's favorite radio, a DAC Mark 10, LOL, as it sports one of the most powerful audio modulation circuits known to CB radio with its 40-watt push-pull audio modulation circuitry capable of driving its 25-watt audio modulation transformer into some nice saturation, which should allow you to both see and hear the wonderful effects of this low frequency harmonic distortion. Now, for those of you not aware, the communications bandwidth is 300 to 3000 hertz, whereas a good home speaker will go subsonic at about 20 hertz, all the way up to a champagne glass shattering 20,000 kilohertz. I'm going to be operating the signal generator at the low end of the audio communication spectrum, which is 300 hertz. I will be bringing this up slowly, and you should be able to see the distortion begin. You should also be able to hear the audio footprint widen out. So with that, let's get this party started. Here we go. First, you will see the 300 hertz, what we call a fundamental signal. And then as the DAC's audio modulation transformer starts going into saturation, you'll see some higher order harmonics appear, second, third, fourth, fifth order harmonics. And if you listen closely, you'll be able to see and hear that little 300 hertz tone as it just starts out as a little bit on the sharp side. And it will actually widen out as the harmonics appear, creating a much fuller, richer sound, really filling out the low end of our communication spectrum audio footprint. And you're also going to see when we approach saturation, full blast, the DAC's modulation meter is accurate, by the way. Once I get up to 100% and slightly exceed that, the magnetics are going to go into full saturation. And much like red line on a car engine, the valves are going to start floating and performance is actually going to decrease. And you will be able to see that here on the modulation meter. So anyways, let's get this thing going. Okay, keyed up the DAC, 300 hertz tone. Bringing it up slowly. So there's the fundamental 300 hertz. And now you can see some higher order harmonics start to appear. And if you listen closely, it's a little wider audio footprint. If I'd shut up, you'd probably hear it, but I'm not going to shut up. I'm going to take it right up the red line, and then I'm just going to go pedal to metal and watch what happens. I'm increasing the audio, but you're going to see the modulation meter go backwards. There, see that? That's full saturation. So those of you guys that think louder is better, well, once you hit saturation, those audio sine waves are just mush. They're not doing you any good. So let me shut up. We'll do this again. All right. Well, hopefully that painted a little better picture, and I'm sure some of you could hear that. Not easy to hear, but it's there. And for sure on the audio spectrum analyzer, you can see it. So there's a demonstration of how running your radio's audio levels. And chances are a lot of you guys are already doing this and don't even know it. You're just below the verge of overmodulation, and that's right where you want to be if you really want the good low frequency coupling of the magnetics used in most of our radios.
Okay, guys and girls, thanks for tuning in and tagging along for what started out as a CB radio video and somehow morphed into a Crash Course 101 in audio circuit design. And that's just myself, Greg Howe, S9 Radio, brainstorming on YouTube. I go off on these tangents often, and in case you haven't realized, I've been at this a long time. I've actually been working as an engineer since a very young age of 17, and privileged to work alongside of some of the best in the business. And Mike Stahl, KLM Antenna, M Squared Antennas founder, owner, actually approached me for some help on a quad antenna design. Now, Mike Stahl and a Stanford University professor back in 1964 made the world's first Earth-Moon Earth communication, helping to make the Apollo mission possible. To have somebody of his stature come to me, my God. And then there's the Bose Corporation. I wrote a technical book on a very rare exotic, well, it's not rare, but a very exotic Sansui amplifier design, and had the Bose Corporation hit me up, as I was the guy that cracked a quirk that these amplifiers had. The only guy in the world, Audio Karma, including myself, for almost 3 decades have been trying to crack this design. I'd spent an hour here, an hour there. One weekend I sat down and said, I'm not coming up for air until I crack this design. About 72 hours later, with my wife threatening divorce, I figured I better crack this design. I did. I wrote all about it, and yeah, been real lucky, as you'll see in my future videos. I know there's a lot of people doing videos. I don't know everything, but when you do see me doing a video, I for sure know what I'm talking about. So once again, thanks for tuning in. I'm also a perfectionist, so I'm really trying to, present this in a way that is, kind of digestible. I know it gets kind of technical, but hopefully you're enjoying it, and I sure look forward to your comments. So far, I've had some pretty good comments saying, "Hey, keep it up," because I'm worried I'm out technology talking you guys and making things kind of boring. But it seems that I had one guy say, "Hey, man, you're the only guy doing this, and we love it." So please subscribe. Let me know what you think in your comments. I've got a lifetime, which is well over a half century of experience I'd love to share with you. Even though I'm retired, I've got better things to be doing. But this is fun. As you can see, I'm having fun with these videos, and hopefully you are too. So with that, I'm going to say 73, Greg Howe, S9 Radio, and stay tuned. Man, oh man, I got a lot of stuff. It's just I'm probably going to have to get some staff in here. It's just way too much and too little time. You know the old saying. 73.